This section introduces the blog post as a proof of concept, POC, for integrating Clarity's tracking functionalities into the Next.js micro SaaS application, post to video. The motivation behind the POC is to address the issue of silent bounce, where users sign up but do not proceed to create a video. Clarity's analytics aim to provide insights into why users drop off. Key takeaways cover the advantages of Clarity. It offers session recordings and heat maps with no cost, is designed for performance using Next.js's afterInteractive strategy, and allows quick debugging by enabling real-time checks via the browser's Network tab. This section outlines the installation process for Clarity, emphasizing the integration of tracking code into the Next.js app router architecture to enable visual UX debugging. Users need to create a project on Microsoft's Clarity platform to sign up and begin setting up their telemetry. A unique project ID is essential for connecting the Clarity project to the analytics dashboard. This includes creating a new project and locating the project ID in the settings. To enable Clarity tracking, a .env.local configuration file must be created in the project's root directory, including the necessary project ID prefixed with next public for browser access. This instruction ensures the layout.tsx file accommodates Clarity's integration by injecting necessary scripts that load only after the application's components have been rendered, thus preserving performance. This section details testing the POC to ensure telemetry is captured correctly within the development environment. It explains how to verify the Clarity integration using the Network tab in Browser DevTools to check that the tracking script loads correctly and that interaction data packets are sent. This part shows how to verify the Clarity script in the browser console, expecting to receive a function output which confirms the script has been executed properly. Users can check the dashboard's real-time analytics to confirm active users and understand that heat maps and recordings take time to process. The section discusses environment-based configuration for telemetry management, explaining how to selectively enable or disable tracking based on the environment, production, or development. It introduces fundamental behavioral analytics concepts used in the POC, such as heat maps, recordings, rage clicks, and scroll depth, which are crucial for understanding user interactions. Instructions for starting the development server and interacting with various UI elements to generate tracking data for review in Clarity's dashboard. This section lists technologies used in the project, specifically naming Next.js, Post-to-Video, DigitalOcean, Google Analytics, and Microsoft Clarity for telemetry. The design section explains the rationale behind choosing and integrating a visual UX debugging tool to diagnose the silent bounce issue. Design constraints detail the requirements any selected tool must meet to fit into the post-to-video architecture, including telemetry support, privacy, cost-effectiveness, integration, and compatibility. The selection of Microsoft Clarity highlights its unique offerings in telemetry and privacy at no cost, differentiating it from other tools that fell short on cost or feature support. This matrix compares implementation options for integrating Clarity, determining that using the native script with Next.js is superior due to its non-blocking load characteristics. The structure of the code for root layout is explained, emphasizing how it integrates Clarity's tracking in a manner that does not impact performance while preserving Next.js architecture. The provided code snippet shows how Clarity scripts are appended after hydration, highlighting the usage of after-interactive strategy and ensuring the integration is seamless with other components. This section presents visual confirmations of telemetry data capture and illustrates how Clarity displays insights on the silent bounce problem. This installation section references the sign-up process for Clarity, including images showing the initial setup steps. It emphasizes the necessity of providing a valid site URL during project creation within Clarity, even for local development testing. The project ID details are highlighted, demonstrating its importance for enabling telemetry tracking for the project. This part of the testing section illustrates how to check the integration results with screenshots, showcasing successful verification of Clarity tracking. An illustration shows how ad blockers may intercept telemetry requests and confirm necessary troubleshooting steps. In incognito mode, users can verify successful data tracking without interference from ad blockers, confirmed by successful HTTP status responses. This part shows the usage section with visuals describing how the home page and various test pages are tracked within Clarity. Custom UI elements designed to provoke user interactions are illustrated, providing insights into rage clicks and dead clicks tracked by Clarity. The main overview of the Clarity dashboard is depicted, showing how user sessions, scroll depth, and active user metrics are presented to the user. The analysis section shows how Clarity's Heatmaps visualize engagement patterns, highlighting areas where users frequently interact with the interface. Session recordings showcase users' interactions, providing insights into behavior and areas of friction experienced during navigation. The technical reference section elaborates on the data flow for Clarity and architectural decisions made for smooth integration with Next.js. This part explains how Clarity effectively captures user data while ensuring that privacy is maintained through masking sensitive information. The implementation section discusses how the Clarity.js executes in a Next.js 16 environment, operating post-hydration to ensure access to the client-side DOM. The comparison between GA4 and Clarity illustrates how they work together, emphasizing that GA4 provides broad metrics, while Clarity offers qualitative insights. Clarity includes an AI copilot feature that summarizes user session recordings, helping identify common trends and UX problems without requiring extensive manual review. Policies related to data retention are detailed, outlining how session recordings are stored and the ethical framework behind Clarity's free model, tying the data back into Microsoft's ecosystem. Operationally, users should be aware of the impact of ad blockers on data capture and strategies for filtering out noise from development activities. The References section lists useful links related to Microsoft Clarity and the Post-to-Video project, providing additional sources for readers.